Well, can they believe it? I tell you what, kid, I tell you what. They look outside now. Right, it's bank holiday weekend, eh? Should be nice and sunny. It's not. It's overcast outside. And I tell you what, I'm stuck in my house right now. It's roasting. I'm absolutely roasting. I'm stuck in shorts here. I'm not going to show you. I don't want to show them off my legs. What is this, OnlyFins? How we doing, everybody? Show Moso, Prince Steel, Tethys or Yorkshire, and today's video I thought I'd do, we're going to talk about a bit serious video, right? We'll do boundaries. As in, you've crossed mine. Dayas. Don't deny it, don't deny it. No, we're not playing this game. I'm not messed about like this. Oh, God. On a serious note, though, we're going to talk about a particular boundary event that occurred during the Cretaceous period. Now, a boundary event is a significant point in time where something dramatic happens, particularly if it's a global event and it happens very short, very sharp, and it's not very good for the animals at the time. And today's topic, we're going to talk about a particular boundary event that I've actually researched a lot in my past. And this is the Cretaceous boundary event known as the OAE2 or the Cenomanian-Turonian boundary event. I wonder, something happened after that. Something happened after this boundary was really significant, particularly to me. I have to think about that. So this boundary event approximately happens around about 93.9 million years ago, but there's a bit of contention whether it's exactly this point, or would it happen a bit before or a bit after, or was it actually stretched over a longer period of time than what we think. There's a lot of evidence to suggest either or camps, but we're not entirely sure. But for the purpose of today's video, we're going to stick with this 93.9 million years ago date because it's more convenient to me. So the OAE2 was a globally impacting oceanic anoxia event. Now, break it down into simple terms, that basically means that the ocean, well, you know how the oxygen levels in the ocean are like that? Well, so all of a sudden they went like, and then all the fishes were like, I don't know if fish are like that anyway, so they don't really breathe there, do they? They breathe water, don't they? Yeah. But additionally, we have evidence that there's a lot of carbon being released into the environment at the time from what appears to be volcanic eruptions around this time, which had a really big knock-on effect with this event. But we know that there was a lot of carbon and a lot of eruptions because we have characteristic black, organically rich shales from around this time. Now, there's probably wondering, well, these black shales, how do we know that this is actually the point? Well, black shales are often a point where there's been a mass die-off of creatures, particularly microscopic organisms, and in today's video we're going to particularly be noting a particular group called the planktonic foraminifera. Now, what are foraminifera? So foraminifera are quite a wide actual subphylum, a group of little microscopic organisms, often referred to as forams, as single-celled, and they actually build their actual shells around themselves, and they can come in various different shapes, sizes. It makes species identification a bit daft with them sometimes, particularly in the fossil record, which we have quite a few thousand species that we know about. Now, some of them lived on the sea floor, some were planktonic, some were free swimmers. There's a whole variety of different locomotion these creatures had. The one factor about foraminifera that's really interesting, really key for this event, is that they are really good at telling us what the environment were like at the time. So certain amounts of certain diversities, certain amounts of populations, presences of certain foraminifera in certain areas can actually tell us a lot about the environment and the health and general impact of the environment upon other creatures. Now, a lot of these creatures are only about less than a few millimeters across, but some of them, like Nummulites from the Isle of Wight, can actually get to about just under an inch across. So there's quite a diversity of these creatures, but they are very significant. So now we've run through some of the key aspects of the actual event and one of the key players, the foraminifera. Let's go through the actual timeline of this event. So phase 1 happens around about 313 to 55,000 years before the OAT, so just before 93.9 million years ago. And, well, to be honest, there's not much here to say. The environment's pretty stable. There's a lot of diverse planktonic foraminifera. It's calm before storm, isn't it? Well, and then comes phase 2, which happens around about 55,000 to bang on the point of the onset of this particular occasion, the OAT2. And there's basically an increase in bottom water anoxia. So the water at the bottom is reducing in oxygen. So everything living down there that's either living on top of the sediments, in the sediments, or around the sediments, it's going. And what's worse is that the temperature around this time, the global temperature, just goes. And what happens? Well, foraminifera diversity just goes. Well, for certain groups it goes. And then some certain groups go like, And interestingly, around this time, we actually get a lot of occurrences of dwarf species of foraminifera around this time, which means that there's not a lot of nutrients and particular substances in the wetter levels that are allowing them to build those tests that they have. So they have to reduce the size of their tests in order to cope. You know, I can't build a big house, I'm going to have to build a shed. Phase 3 happens around about 100,000 to 900,000 years into the OAE2, and this occurs around a time that we call the Bornerieli event. I can't pronounce that, but it's on screen anyways. But this is actually significant because it's an indicator of these black shales, and what happens around this time is that we get a large amount of radiolarians. Now these are other small microorganisms that I'm not going to really detail here, but I'll detail another video at some point. But this indicates there's a lot of nutrient-rich influx into the environment. So there's a lot of nutrients being pumped in the environment, and that I would think that's a good idea. That's a good thing to happen, but it's a bit naff. I'll tell you why. Because a lot of planktonic organisms feed off these nutrients, and they reduce the oxygen levels in the water, particularly towards the top. So there's got oxygen reduction here, there's got oxygen reduction down here, and everything in between is. And then phase 4, which happens around about 930,000 years into the OAE2, it's pretty similar to phase 2, to be honest with you. Not really much to say. And then we end it with phase 5, which is around about 118,000 years into the recovery after OAE2, where you get some rebound of some certain foraminifera groups, but there's some that are remaining quite abundant and others that aren't. But there are still some environmental issues. So this was a really bad event, really bad, and I'll tell you why. So if it weren't obvious, a lot of microscopic faunas and organisms, they were impacted very, very badly, particularly foraminifera, which they were hit very hard, very, very hard. But also you got your oysters, your clams, your sort of bivalves, your creatures like that, particularly rudis, which is all these like sort of long columnar bivalves. They look almost like corals. They were hit pretty badly because there's a reduction of calcium in the water levels, and they need that calcium to basically make their shells. They've got no shell, they've got no shelter. Ammonites, they were hit pretty hard, and particularly in Europe, they declined like madness, which probably explains why around my birthday when I went to the chalk, couldn't find any. I've got the Cenomanian-Turonian boundary event to blame for my lack of fossils. Now, bioturbation and trace fossils, which is basically just, that's the record of animal behaviour. Now, in the sediments in the oceans, we've got a massive reduction of bioturbation and trace fossils, which means that there's a massive reduction in life down there because of the anoxic event. It's basically just no oxygen, so no life, and therefore, actually, because there's not enough nutrients being released from the sediments to feed the bottom matter, we've got nothing living down there, so the whole food chain collapses down there. However, that's probably come to see the vertebrate impact around this, so let me sit you down. The biggest one is ichthyosaurs. Ichthyosaurs, this is their penultimate, this is their final act almost. They pretty much go extinct into the early Turonian around this point, but the Cenomanian-Turonian boundary event was a big kicker to them. And not only that, but the pliosaurs, they start to go into decline, into extinction around this time. Tethysoucian crocodilians, they actually suffer badly. They reduce their environmental distribution down to warmer areas. You've got your dolichosaurs, which are cousins to a significant group, but they go into reduction as well. And then after this, after the OAE2, a particular group, they get very successful, very, very successful. I can't think what they are. So let's go into the sort of causes of this event. What were the causes of the OAE2? Now, before the OAE2 itself, there was a lot of volcanism. There's what was a lot called LIPs, or large igneous provinces. Basically, volcanoes are pumping out a lot of magma and a lot of carbon dioxide into the atmosphere, which actually increases the global temperature just before the OAE. So there's a lot of turmoil with the environment of that. So obviously, hotter temperatures means that the environment can't catch up, right? Yeah, you with me so far? But then also occurring around this time is what we call the Plinius cool event, which is basically a cooling event. And this is actually due to a lot of carbon being incorporated into the marine realm, particularly the sediment. So a lot of this carbon is getting locked up, and what happens is that the global temperatures, because there's not enough carbon keeping it warm, they drop by about 4 degrees. That's a lot. I mean, 4 degrees is a difference in the UK between a hot day and a cold day. Well, frozen if they like. But this also is interesting because around this time we got the global volcanism going on, which means that this cooling event was like a sort of small puncture and then it recedes. It's really bizarre. There's a lot of evidence saying, well, the world was cooling and heating at the same time. which don't make sense, but hey ho. But the volcanic gases around this time as well, they cause a problem in its end. They cause ocean acidification, which basically means the reduction of calcium in the environment, and also, well, shell generation by shelled creatures reduces, and that's why you've got your sort of dwarf foraminifera, and you've also got your reduction in bivalves in particular, and also the ammonites get affected there. So yeah, a lot of gases, not my gases, we don't want my gas in the environment, but a lot of gases are impacting the whole circumstance in the ocean. Now, the big factor in this is the anoxia, so basically the reduction of oxygen in the water levels. But what's happened here? Well, it's to do with those planktonic organisms from earlier. Well, basically what's happened is that a lot of plankton blooms are occurring because of this nutrient input from various other places, and this reduces the oxygen levels, and that causes a knock-on effect in the water levels, and it just causes basically everything down at the bottom particularly to suffocate to death. Essentially, reduced oxygen levels means that reduced life, and that's when we get our organically rich black shales. What we also get around this time is that it looks like the Earth is going through a particular phase in what's called the Milankovitch cycle, and this is where the Earth is in a certain position around the orbit of the Sun, and this can impact, well, the environment depending on how close or how far or what the tilt is of the Earth around that time in the environment. And it just so happens that around this time it's going through a bit of a shift, which means that all those problems I mentioned earlier, they're getting exacerbated by the fact that the Milankovitch cycle is going through a little bit of a phase. And the Earth was at this time as well, the Cenomanian-Turonian boundary event. Ooh, dear, dear, dear. There's a lot of phosphorus also being pumped into the environment, particularly into the marine realm. And this was a problem because organisms that intake a lot of phosphorus into their bodies and into their makeup, they're not able to take it in because of the ocean acidification, which means there's an overflow of phosphorus into the atmosphere, into the environment. And this actually, they never guess, this increases the anoxia. So even more creatures are going, "Arr!" And the final factor is, well, it's actually quite simple. Sea level rise. Around this time, during the Cenomanian particularly, the sea levels were probably their highest they've ever been. And what does that mean? Well, when you increase sea levels, you deepen shallow environments, which means you expose these shallow environments to increased anoxia from there being, there's too much water on top of me, and there's, oxygen levels, the OAE 2, I was hoping not for this to be such a long video, but a really interesting event. Basically, the world went kaput. There's a lot of factors involved, and it seems like that everything just went right for there to be a problem. Now, it's a less talked about extinction level event. It's not that big of a level. Basically, it had a bit of an impact, and it had such a significant impact that we saw basically the last swan song of the ichthyosaurs and the sort of near penultimate act of the pliosaurs. But then there was a particular group that they did right well afterwards. They did right well. I can't think, what do they call them now? What do they call them? Zoophactinids. That was the word, zoophactinids. Nah, I'm being daft. Of course it was the mosaurs, but anyways, hope you found this video quite interesting. And please do some reading up on this event. It's really interesting, really weird. But thank you very much for watching this video. Hope you're having a wonderful day, and I'll see you later. Ta-da, bye.